Hi, I'm Rich with Inside HPC. We're here at the GPU Technology Conference in Silicon Valley, and today we're at the NSULATE booth with Alex. Alex, let's start at the beginning. Who is NSULATE and who do you help?
All right, Rich, NSULATE is an exascale storage technology company. So we build exascale storage technology solutions for extremely large data centers, big data systems, supercomputers, and today for actually anybody doing any kind of large big data storage problems. Well, you're going to see a demonstration of the NSULATE warp drive today. The warp drive here is a demo box. We have a bunch of electrical engineers who built this box for the sole purpose of destruction. So this is just meant to do a sexy demo. But we're actually on the advanced HPC booth because they're launching the Orion storage server using our software. So this wonderful box over here can hold 1.4 petabytes of data on 100 drives in a 4U unit, and it uses an NVIDIA P4 graphics processor, a GPU, to run the file system. Okay. So what you're going to see for the first time ever is a video card running a Linux file system better than a RAID controller or a CPU can do it.
Okay, now I'm intrigued. So can we see how it works?
Sure, absolutely. Okay. So the screen, the graphic display you're seeing here is being displayed by an NVIDIA P2000 GPU. It's a video card.
Yeah.
Now over here you see we've got a lot of flash drives sitting in the array.
Yeah.
There's 144 of them.
Yeah.
Configured in 6 JBODs.
Yeah.
So this is 6 JBODs, each with 24 drives.
Okay.
Just a bunch of disks, that's what JBOD means. If you're in HPC computing, but on the storage side.
Yep.
So we got one motherboard in there, and that NVIDIA GPU, the same one that's controlling that screen, is running the file system. Linux thinks this is one big hard disk. As far as Linux knows, we're just running one giant file system on top of this thing.
Gotcha.
Now what we're going to show you is something crazy. This technology was originally developed for the Square Kilometer Array telescope. So they're trying to process and store 80 petabytes of astronomical data a day, and the cost of the network fabric and the storage was 70% of the budget for the project. So they asked us to come up with a solution for reducing the cost of storage by 50 to 70%. And this technology accomplishes that. So I'm going to show you something nobody else has ever seen before. This is the first version of the product launching today.
Okay.
All right. So we're going to run, go ahead, Raph, fire it up. So what we're going to show you here is we have stored a video on this storage array. There it is.
Yep.
That's a 4K raw video uncompressed. There's only one copy of it on this array. Now you see the lights flashing there?
Yeah.
This array is all running in parallel. Every frame of the video, all of it is stored in all across this array in pieces. The GPU is reassembling it in real time.
Oh, okay.
So what happens, for example, if a drive breaks?
You live swapped it out, yeah?
If it broke, this is a broken, it's gone, it's dead, I can't use it again, right?
Yeah. Okay.
Damn it. So you see some error messages coming up. Blocks.
I see that.
Notice my video's still playing. So the GPU detected that the data is missing, solved a huge system of linear algebra equations in real time to figure out what that data was that used to be there, and puts it back on the screen without noticing the data's gone.
Okay.
Now this is the same thing a RAID controller does on a little scale.
Yeah.
If I was using a RAID controller, I could pull 2 disks out and my video would still work.
Yeah.
If I pulled a third one out, I would crash and the array would fail. But fortunately, my GPU can handle 3 drive failures. If you stored your data on Amazon, you could pull 4 drives out and not lose your data. But if you had 5 drives on Amazon fail, you'd lose all your data. But I'm still working. If I stored this on a state-of-the-art enterprise-grade storage array used by any large company whose brand I won't name, you could lose 5 drives, but if I pulled 6 drives out, you'd lose your data.
Okay.
However, this array is running erasure encoding, that's error correction, supercomputed at 2 orders of magnitude the scale of anything any RAID controller is capable of. So we can do...
Wait, it's still playing though. Alex, you just pulled out at least a dozen drives out of this.
Fail a whole node. There we go. Boom. So this array, just for demo purposes, that's why we had to build it in the gun case so it can handle some abuse, can handle mathematically up to 255 drive failures. We configured this for demo purposes for just 76, so we can have fun. But we're just showing off now, it's just disgusting.
Yeah.
Eventually, I'm gonna fail this JBOD here, so this entire one's gonna go down.
Okay.
And damn it, that's still not enough. I'm gonna fail, go ahead, you do the honors. flip a switch. Just hit it.
The red. Here we go.
Turn off. Hit the red switch.
Flip the switch.
Boom. That probably killed us.
Okay. Yeah.
It's doing a bunch of math. It says, I can no
I did
longer
it.
prove that the data's there.
Sorry.
See?
You broke it.
You broke it,
I was
finally.
able to- yeah.
So the beauty is that an ordinary storage array, you could never build one on this scale. The video processor, we're here at a GPU conference.
Yeah.
There's a bunch of guys going, I need to store a petabyte of cat pictures in order to train my cat AI recognition algorithm. I have the biggest GPUs in the world sitting there idle, waiting for data to trickle off my storage system.
Yeah.
So they're wasted.
Yeah.
This architecture here, you do your artificial intelligence and neural network on the same device that's storing the data directly on the local machine at the full bandwidth of the GPU. So it's vastly more efficient than any kind of storage architecture built today using traditional technologies. So the Orion server over there can handle 100 drives, 1.4 petabytes. You can have any 10 of the drives fail, which is half what you'd put in an ordinary storage array, and the system will stay running. You don't have to worry about it. You can even leave it broken, and the array has not, well, it's broken now.
Yeah.
You can leave it broken with some drives, and the array runs at the same speed. So the GPU is actually superior for storage processing compared to any storage technology. This is the first time you'll see this live, but 10 years from now, nobody will ever heard of using a RAID controller for storage because GPUs are better now.
Wow. Well, Alex, I totally get the value of this because the SK8 telescope is going to run in remote, nasty places.
Yes.
Africa in the middle of the desert and Australia, right, and extreme environments, and these things are going to fail. And this seems to be a great technology to keep them up and running.
Yes, sir. In fact, this is already running at the Murchison array in Perth, handling all the live data coming from the MWO array. That's where it was developed. But now it's going into data centers and Oregon State University, and you're going to hear a number of other customer announcements because you're at the launch of the technology. So this is the 1.0 shipping today.